3 Atlas is carrying enough carbon dioxide to jumpstart a dead planet's atmosphere, and it's heading straight for Mars with the timing of a Swiss atomic clock. Why is this interstellar visitor getting so close to the red planet just after NASA announced potential life signs in ancient Martian rocks? The timing is statistically improbable. Tonight we dissect a cosmic coincidence that has astronomers whispering and conspiracy theorists screaming. This isn't random. In a cosmos often ruled by chance, nothing should be this precise. Something strange is happening in Mars's orbital neighborhood that challenges our understanding of celestial mechanics, and what Atlas is doing out there may be the most consequential discovery in human history. Part 1. The Discovery. For more than 4 years, NASA's Perseverance rover has been drilling into the ancient mudstones of Jezero Crater. In July 2024, scientists uncovered something extraordinary in a sample named Shiava Falls, leopard spot textures embedded in the rock. These aren't decorative patterns. They are candidate biosignatures, physical and chemical traces that, on Earth, are often produced by biological activity. Minerals like vivianite and grigite accompany these textures. While abiotic processes can create similar minerals, on Earth they frequently trace microbial processes. The analogy is blunt: footprints in ancient mud, except these prints might have been left by microscopic Martian organisms 3.5 billion years ago. Jezero wasn't always a dusty basin. Billions of years ago, it hosted a lake fed by rivers and deltas. Deltas are nature's archives, layering sediments that preserve organic molecules and biological signals. So when Perseverance returned evidence consistent with preserved biology, the scientific community treated it with serious, careful excitement. Candidate biosignatures demand skepticism and replication, but they also demand attention. Part 2. The Interstellar Visitor. While eyes turned to Mars, another story unfolded in the deep dark. On July 1, 2025, the Atlas network flagged an object unlike any other. Named 3 Atlas, it became only the third confirmed interstellar visitor in human history. Atlas, the asteroid terrestrial impact last alert system, surveils the sky for hazards. What it found was different: a hyperbolic trajectory with eccentricity above 1, a one-way interstellar path. This object is not bound to our sun. 3 Atlas shows no signs of artificial control, no radio transmissions, no engineered maneuvers. Yet its chemistry is odd. Spectroscopy from space-based and ground observatories revealed a comet dominated by carbon dioxide, with a CO-to-water ratio near 8:1. Most comets are water-rich. This visitor appears to be breathing carbon dioxide. Observers also reported a greenish glow, possibly diatomic carbon or cyanide compounds outgassing, details that hint at an origin and thermal history unlike the typical icy bodies we know. Part 3. The Coincidence. Here's the spine-tingling part. As scientists announced Mars' strongest biosignature candidate, 3 Atlas was barreling toward a close approach to Mars. Its trajectory brings it within 30 million kilometers of the planet, and crucially, that flyby occurs while the object slips behind the sun from Earth's perspective. The timing looks remarkably, almost unnervingly, coordinated. Online, conspiracy narratives proliferated: alien probes, terraforming tools, intentional seeding. Scientists responded with caution. Current observations are consistent with a natural body, and there is no evidence of artificial origin or imminent danger. Still, if you ask what would be an effective delivery system to warm Mars and thicken its atmosphere, a CO2-rich comet is a plausible candidate. Coincidence or design? The data don't indicate intelligence, but the pattern provokes the question. Part 4. Chemistry and Consequences. If a CO2-rich body deposited volatiles onto Mars, atmospheric pressure and greenhouse effects could increase, potentially nudging climate conditions over long timescales. Scale and proximity matter. 30 million kilometers is a close approach astronomically, but far from impact. Significant atmospheric modification would require direct deposition or repeated large deliveries. Still, modeling how ejected CO2, dust, and organics interact with Martian regolith and atmosphere is essential. Astronomers are mobilizing radio arrays, infrared telescopes, and high-resolution imagers to map thermal signatures, search for faint tails, and measure outgassing. Planetary protection teams are reviewing protocols, not due to biocontamination fears, but because interstellar visitors force questions about cross-contamination and scientific stewardship. Each spectrum and light curve recorded in the coming weeks will refine hypotheses. Part 5. Natural Explanations and Tests. Several plausible, natural scenarios exist. 3 Atlas could be a fragment from a carbon-rich protoplanetary disk, violently ejected during planetary formation in another system. Alternatively, long exposure to cosmic rays and stellar winds might preferentially remove surface water ice, leaving a CO2-dominated remnant. Internal heating events could alter composition too. These hypotheses are testable. High-resolution spectra will measure molecules and isotopes. Monitoring will reveal fragmentation or activity. Thermal imaging can constrain internal structure. If the timing and chemistry point to a natural origin, the story is extraordinary but not supernatural. If not, it would demand a paradigm shift in how we think about interstellar exchange and planetary engineering. Part 6. Broader implications. If confirmed as a CO2 delivery mechanism, 3 Atlas forces astrophysicists and astrobiologists to reassess interstellar material exchange. Panspermia concepts, the distribution of prebiotic compounds between systems, have been speculative for decades. This event provides urgency. Could building blocks of life hitch rides across light years within robust icy or carbon-rich bodies? Testing requires lab simulations, isotopic studies, and cautious imagination. Conclusion: between wonder and wariness. For now, balance skepticism with wonder. The universe excels at creating patterns that tease human pattern recognition into seeing intent where none exists. Yet sometimes a pattern signals deeper truth. We are privileged observers of an intersection between instruments and curiosity. Whether this episode ends with a mundane explanation or a revelation that reshapes our thinking about life and interstellar exchange, 3 Atlas has already enriched our questions about chance, design, and connection across the stars. Throwing a ball straight up into the air, it follows a simple parabolic arc. It slows, stops for the briefest instant, then falls back down under Earth's gravity. But now imagine throwing that same ball with such incredible force that it never comes back at all. Instead of arcing and falling, it escapes Earth's gravitational pull entirely. That, on a cosmic scale, is exactly what astronomers mean when they talk about a hyperbolic orbit. When astronomers measure an orbit's eccentricity, they're really describing how stretched, elongated, or circular the path is. A perfect circle has an eccentricity of 0. Earth's orbit around the Sun is slightly oval, with an eccentricity of only about 0.017. But when eccentricity climbs above 1, the orbit ceases to be a loop. It becomes an escape trajectory, a one-way path carrying an object away from the gravity of its host star, never to return. And that's exactly what makes 3I Atlas so remarkable. With an eccentricity well above 1, it proves conclusively that this object originated outside of our solar system. It is not native. It is interstellar. That instantly places it in rare company. Only the third confirmed interstellar visitor in all of recorded human history. The first was the enigmatic cigar-shaped Oumuamua, discovered in 2017. Which startled the world when it displayed strange, non-gravitational acceleration. It sped up in ways scientists struggled to explain. Theorists proposed outgassing, solar radiation pressure, or more controversially, artificial origin. Then came 2I/Borisov in 2019, a far more conventional comet, complete with a glowing coma and a tail of dust and gas, behaving much like the comets we know. Now enters 3I/Atlas, a visitor that seems to fall somewhere between those extremes. It shows no artificial traits. There are no geometric structures, no anomalous maneuvers, no radio transmissions. In every way, it looks natural. And yet its chemistry is utterly unlike anything we've seen before. The James Webb Space Telescope, humanity's most advanced eye on the cosmos, has been tracking 3I Atlas since its discovery. Its findings defy expectations. The coma, that fuzzy halo of dust and gas surrounding a comet's solid nucleus, isn't dominated by water vapor, the signature we almost always expect. Instead, it is rich in carbon dioxide with a CO2 to H2O ratio of about 8:1. That is among the highest ever recorded for any comet. To put that into perspective, most comets are often described as dirty snowballs. As they near the sun, heat sublimates their water ice, producing familiar jets of vapor, dust, and trace gases. But 3I Atlas behaves differently, exhaling carbon dioxide as if it were a massive block of dry ice steaming in warm air. This oddity suggests several intriguing possibilities. Perhaps it formed near the carbon dioxide ice line of its home star system, where CO2 could freeze while water remained gaseous. Or maybe millions of years of exposure to interstellar radiation alter its surface, creating a carbon-rich crust that vents CO2 preferentially. Another theory, selective sublimation. If its nucleus is coated with a layer of CO2 ice, it might suppress deeper reservoirs of water ice, skewing the observed chemistry toward carbon dioxide. And there's more. As 3I Atlas approaches the Sun, its chemical portrait is beginning to shift. Observations have now detected carbon monoxide, carbonyl sulfide, and even hidden water ice beneath its CO2-rich exterior. Each detection deepens the mystery, offering a layered history frozen into this alien traveler. The Sphere-X Space Telescope, with its specialized infrared instruments, has confirmed Webb's measurements, proving the results weren't flukes. This is real. This comet is chemically unusual. Then came the glow. In September, ground-based astronomers reported a strange emerald tint in 3I Atlas's coma. This green coloration is a telltale sign of diatomic carbon, pairs of carbon atoms bound together, or possibly the cyanide compounds. Neither is unprecedented in comets, but the abundance of these chemicals in an interstellar object is baffling. It raises profound questions about the chemistry of distant stellar nurseries and how different solar systems might manufacture their icy wanderers. Unsurprisingly, the internet erupted with speculation, theories about alien probes, terraforming tools, or engineered delivery systems for greenhouse gases. Scientists, though, have been more cautious. NASA and ESA experts stress that all the evidence so far is consistent with natural origins. As Dr. Alan Fitzsimmons of Queen's University Belfast put it, yes, the chemistry is unusual. But no, we are not seeing artificial structures, coherent signals, or impossible physics. This is natural science pushing against the boundaries of what we assumed comets should be. Still, uncertainties linger. Early spectroscopic data is always messy, vulnerable to dust contamination, Earth's atmospheric interference, and the shifting geometry between comet, sun, and Earth. Ratios can evolve dramatically as solar heat digs deeper into the nucleus, potentially unveiling a completely different interior composition weeks from now. We are, after all, analyzing a fast-moving, volatile chemistry set flying through space at 30 kilometers per second and tens of millions of miles away. The fact that we can measure anything is astonishing. The fact that those measurements overturn expectations is unsettling. And now comes the timing. As 3I Atlas rushes inward, its trajectory will bring it remarkably close to Mars. And carbon dioxide is no trivial gas where Mars is concerned. It is the primary component of the Martian atmosphere, the greenhouse gas that once kept the red planet warmer and wetter billions of years ago, when rivers flowed and lakes pooled. If one were designing a delivery system to nudge Mars back toward habitability, carbon dioxide would be a prime candidate. It could thicken the atmosphere, trap heat, and begin to shift the climate. That possibility, however speculative, has not gone unnoticed. But let's ground ourselves. For now, we are dealing with chemistry that is unusual but not impossible. With timing that is remarkable but not supernatural. With a trajectory that is coincidental but eyebrow-raising. And the most important date is approaching fast. October 3rd, 2025. That is when 3I Atlas will sweep past Mars at a distance of 28 to 30 million kilometers, about 0.19 to 0.2 astronomical units. For scale, that's around 75 times the distance between Earth and the Moon. Not close enough to strike, but close enough to matter, close enough that the world's telescopes will be watching every second. So the questions now are unavoidable. Why now? Why this chemistry? And why Mars? Because sometimes, even in a universe ruled by chaos, events line up so perfectly they demand our attention. And 3I Atlas, this strange carbon dioxide-breathing visitor from the stars, may be about to show us something that reshapes how we think about comets, planets, and perhaps life itself. The Moon is from Earth, close in cosmic terms, but never truly a near miss. Yet, what's happening with Comet 3I Atlas feels like something pulled straight from a cinematic script. Just as this interstellar traveler makes its closest approach to Mars, it will vanish from Earth's sight. The reason? Solar conjunction. From our perspective, Atlas will slip behind the sun, swallowed by the solar glare, like a whisper drowned out by a symphony. For several crucial weeks, from late September through late October, Earth-based telescopes will be blind. We'll know the comet is there sweeping past Mars, but we won't be able to watch. The timing feels orchestrated, almost as if the universe is setting the stage. Think about the drama. Maximum proximity to Mars coinciding with maximum invisibility from Earth. If you were writing a science fiction thriller, you couldn't craft better suspense. By October 29th or 30th, Atlas will reach perihelion, its closest approach to the Sun, skimming just inside Mars' orbit at about 1.4 astronomical units. That's the sweet spot, close enough for solar heating to trigger violent outgassing, while maintaining that tantalizing nearness to the red planet. But we won't be entirely blind. The European Space Agency has confirmed that orbiters around Mars will attempt direct observations during flyby. Mars Express, which has been circling since 2003, and the Trace Gas Orbiter, active since 2016, will be our cosmic detectives. They might capture what Earth cannot. What could they see? High-resolution imaging may reveal the nucleus, the coma, perhaps even tail structures invisible to Earth. Ultraviolet and infrared spectrometers could expose fingerprints of cyanide, carbon monoxide, and exotic compounds, while dust analyzers might even scoop particles from the comet's wake. That would mean direct samples of interstellar material, opportunity scientists can only dream of. The stakes are monumental. This is only our third known interstellar object, and unlike Oumuamua or 2I Borisov, Atlas carries a peculiar fingerprint, an unusually high carbon dioxide content. Understanding its chemistry might reshape how we think about the formation of planets across distant stellar nurseries. And then there's Mars. The red planet has been under renewed scrutiny since potential biosignature textures were detected in Jezero Crater. Billions of years ago, Mars had rivers, lakes, and a thicker, Earth-like atmosphere. Today, it's a frozen desert wrapped in a thin carbon dioxide shroud. But what if 3I Atlas brings a clue? Its carbon dioxide-rich chemistry is strikingly similar to what Mars would need for atmospheric replenishment. Of course, perspective is key. One comet isn't enough to terraform a planet. Adding Atlas's carbon dioxide to Mars would be like pouring a cup of water into an empty swimming pool. Mars has lost its atmosphere for billions of years, stripped away by solar winds due to its weak magnetic field. But what if Atlas isn't alone? What if this is part of a long-term delivery system? Cosmic couriers that slowly contribute to planetary restoration. Here's the reassuring news. Atlas poses no threat to Earth. Its closest approach to us won't be until mid-December, and even then it will be a safe 1.8 astronomical units away, around 168 million kilometers. That's farther than the Sun itself, making it less dangerous than the radiation we live with daily. Still, the geometry is stunning. An interstellar visitor rich in the exact gases Mars needs, arriving just as we uncover the strongest evidence yet for ancient Martian life. And during the critical window, Earth won't be able to see it. If this were a Hollywood script, editors might reject it as too coincidental to be believable. When Earth resumes observations in November and December, Atlas may look completely different. Solar heating will have stripped its surface layers, perhaps exposing deeper secrets frozen for millions of years. By then, it could be a transformed object, altered, reshaped, even reborn. But here's the sobering truth. Unlike Oumuamua, Atlas's timing makes an intercept mission impossible. The comet's speed, trajectory, and distances are far beyond our current technological reach. We are left with telescopes, spectroscopic tools, and whatever Mars orbiters can capture in those fleeting days. Maybe that's how it should be. Some mysteries aren't meant to be touched, only observed, only wondered about. Atlas carries its cosmic cargo, carbon dioxide, exotic volatiles, and perhaps even chemical echoes of distant stars, toward Mars while Earth looks away. And we are left asking, what will happen in those invisible weeks? What will the orbiters witness? And what story will Atlas leave behind when it emerges again into our skies? The orbital mechanics are precise. The chemistry is puzzling. The timing is uncanny. In just a few weeks, an object from the stars will glide past Mars, hidden from our view, daring us to connect the pieces of its story. Now consider the suspicious timing. In September 2025, NASA announced the strongest evidence yet for ancient Martian life. Just weeks later, 3I Atlas, loaded with carbon dioxide, sweeps by Mars. At the exact same time, Earth is blinded by solar conjunction. Rational science says it's coincidence. But to the human mind, pattern-seeking, story-weaving, it feels meaningful. Interstellar objects don't follow human calendars. Atlas began its journey millions of years ago, its hyperbolic trajectory locked by stellar encounters long before our species even existed. The laws of physics don't care about our discoveries. Its eccentricity, greater than 1, proves it's unbound to the sun, destined to leave our system forever. Still, coincidences pile up. The geometry of perihelion places Atlas just inside Mars' orbit, heating maximally, while hiding from Earth. Its chemistry is rare, carbon dioxide dominant, exactly what Mars would need to rebuild its lost atmosphere. And its invisibility during the encounter creates a perfect window of cosmic privacy. If you wanted secrecy, you couldn't plan it better. NASA has been clear. Atlas shows no signs of artificiality. No propulsion, no structured signals, no geometric perfection, only natural cometary behavior. And yet, from a narrative lens, it's hard not to see design. Maybe not aliens. Maybe not intelligence. But perhaps the design of nature itself, the possibility that the universe tends to produce interstellar objects whose chemistry aligns with planetary habitability. What if this isn't coincidence, but pattern? What if carbon dioxide-rich comets are part of a cosmic delivery system, seeding atmospheres, sustaining habitable worlds? The speculative track invites us to imagine water for rivers, CO2 for warming, organics for chemistry, the very cocktail detected in Atlas's coma. Skeptics remind us, even if Atlas deposited its entire mass into Mars's atmosphere, the solar wind would strip it away eventually. The red planet lacks a magnetic shield. Any gain would be temporary. But maybe Atlas isn't the whole story. Maybe it's part of something larger, multiple deliveries across cosmic time. 3 interstellar visitors in less than a decade suggests they may be more common than once thought. Perhaps our detection tools are only now catching what has always been happening, a cosmic rhythm of delivery and renewal. There are 2 ways to read this story. The scientific track sees coincidence, natural chemistry, orbital inevitability. The speculative track sees pattern, timing, meaning. Both acknowledge mystery. Both leave us with questions. And perhaps that's the point. What if Atlas isn't here to terraform Mars or prove alien intent, but to test us? To challenge whether we can hold 2 truths, that the universe is stranger than we imagine, and that extraordinary claims demand extraordinary evidence. In the end, Atlas is more than a comet. It's a mirror, reflecting not just cosmic chemistry, but the limits of our perception, the hunger of our pattern-seeking minds, and the delicate balance between skepticism and wonder. Throwing a ball straight up into the air makes it follow a parabolic arc, slowing down, stopping for a heartbeat, and then falling back to Earth. But imagine throwing that ball so powerfully that it never returns, instead escaping Earth's pull forever. That's the essence of a hyperbolic orbit on a cosmic scale. Astronomers describe this using eccentricity. A perfect circle measures at 0. Earth's slightly stretched orbit sits at just 0.017. But once the value passes 1, you're dealing with a path of escape, an object that will never return to its parent star. 3. Atlas has an eccentricity far above 1, locking in its interstellar origin and placing it in the rare company of only 2 other known wanderers, the cigar-shaped Oumuamua and the more conventional Borisov. Oumuamua sparked wild debates with its inexplicable acceleration that defied simple physics, while Borisov behaved like a classic comet. 3. Atlas seems to sit in between, clearly natural yet carrying a chemistry that makes scientists uneasy. The James Webb Space Telescope, humanity's most advanced cosmic eye, immediately turned its gaze toward the newcomer. What it saw defied expectations. Instead of a coma rich in water vapor as is typical, this one is overwhelmed by carbon dioxide, an astonishing 8 parts CO2 for every single part water. To put that into perspective, most comets are frozen mixtures dominated by water ice, releasing vapor and dust when warmed by the sun. They are the so-called dirty snowballs of the cosmos. But 3. Atlas is more like a giant piece of cosmic dry ice, hissing carbon dioxide into space. Scientists scrambled to explain it. Perhaps the object formed in a region of its birth system where CO2 froze but water remained vapor, capturing an icy crust of carbon dioxide. Or maybe millions of years drifting in the radiation fields of interstellar space transformed its surface into a carbon-heavy shell. Another possibility is that what we're seeing is simply a surface layer of CO2 masking deeper water ice, which will reveal itself as the sun heats the object further. Early observations detected not only carbon dioxide but also hints of carbon monoxide, carbonyl sulfide, and eventually buried water ice beneath the outer shell. These compounds gradually joined the puzzle, creating a layered story of formation and transformation. The Sphere-X Space Observatory later confirmed Webb's findings, reinforcing the mystery with independent measurements. Then came the glow. Observers from Earth's surface began to notice a strange emerald shimmer surrounding the object, a luminous haze that spoke of dicarbon molecules or possibly cyanide compounds. Neither substance is exotic in itself, but in such concentrations around an interstellar visitor, they raise profound questions about the environments that forged such chemistry. Predictably, the internet erupted. Was this an alien artifact, a probe, a deliberately engineered comet designed to deliver greenhouse gases where they are most needed? NASA and ESA responded calmly, emphasizing that all data so far aligned with natural origins. No signals, no structures, no evidence of technology, only an unusual blend of ices and gases. Yet astronomers could not escape a nagging sense of unease. Measuring such chemistry from millions of miles away is a feat already bordering on impossible, and margins of error loom large. Dust in the coma, atmospheric distortions on Earth, and the changing proximity of the comet all create uncertainties. Still, the signal was clear enough to suggest something extraordinary. What troubled researchers even more was the timing. Carbon dioxide is not just an unusual cometary gas. It is also the essential greenhouse molecule of Mars, the very thing that once allowed the red planet to sustain a thicker, warmer atmosphere billions of years ago. If one were designing a delivery system to reawaken Mars, to restore some fraction of its ancient climate, a comet packed with CO2 would be ideal. And yet here, by pure coincidence, is a comet doing just that, swinging close by the planet just weeks after NASA confirmed one of the most compelling biosignatures in Martian history. The coincidence borders on unnerving. Astronomers mark their calendars. October 3rd, the day the comet will pass within 30 million kilometers of Mars. That may sound like a wide gulf, but in cosmic terms, it is a near miss. It will not crash into Mars, nor even brush against its atmosphere, but the sheer volume of gas streaming from its coma ensures that Mars will not pass unnoticed. Billions of tons of carbon dioxide will be left drifting through interplanetary space, some of it trailing into the Martian orbital neighborhood. The scenario is not one of impact but of influence, a faint yet provocative whisper of greenhouse gases brushing against the world we dream of one day restoring. Mars itself is no stranger to such encounters. Billions of years ago, it endured a rain of icy bodies during the late heavy bombardment, some of which may have delivered the water and organics that filled Jezero Crater with rivers and lakes. But in the thin present-day atmosphere, such contributions are fleeting. Any injected carbon dioxide would disperse quickly into the void, yet the symbolism is undeniable. A comet from another star system, saturated with the very gas Mars most desperately lacks, gliding past at the very moment humanity confirms the planet once hosted potential life. Some researchers quietly admit that they feel a sense of narrative at play, as if the universe itself is staging a performance. Skeptics argue that it is all chance, that coincidences inevitably occur when billions of celestial bodies move through space. Yet others whisper that sometimes chance feels indistinguishable from intent. After all, this is not just any comet. This is one of only 3 interstellar objects ever found, and it arrives laden with the most Mars-relevant chemistry imaginable. As the comet draws closer, instruments across Earth and space prepare for a deluge of data. Radio telescopes will measure its coma, orbiters around Mars will sniff for any trace of unusual gases, and Webb will continue dissecting its spectral fingerprint. Every observation may bring clarity or deepen the mystery. For now, the unanswered question lingers in the silence between data points. Why now, why Mars, and why this particular chemistry? The narrative builds like a tension-filled symphony. On one side, cautious scientists repeat the mantra of coincidence and natural variation. On the other, the timing gnaws at the edges of reason, as if a pattern is demanding recognition. Somewhere between those poles lies the truth, waiting for October's flyby to either reveal nothing more than a strange but natural rock from the stars, or hint at something much greater, something that could change how humanity perceives its place in the cosmos. As the comet continued its relentless approach, the solar wind began sculpting its growing tail into an elegant stream of dust and gas stretching millions of kilometers into space. Telescopes tracked the transformation with awe. The closer it drifted toward the inner solar system, the more volatile ices evaporated from its surface, revealing fresh chemical signatures. Ground observatories recorded an expanding halo of carbon dioxide enveloping the nucleus, while space-based instruments refined measurements of exotic compounds. Dicarbon remained prominent, lending the comet its shimmering green hue, but new features appeared in the spectrum, traces of nitrogen-bearing species and subtle hints of organic molecules that suggested complexity rarely seen in such abundance. Mars, still weeks away from the encounter, spun silently under its thin sky. The Perseverance rover carried on with its sampling campaigns, drilling into rocks older than any mountain chain on Earth. Buried inside those stones, the leopard spot textures continued to haunt researchers, whispering of a biosphere lost to time. The coincidence grew heavier as each day ticked by. Here was evidence that life might once have thrived, and out there in the dark was a wandering messenger trailing the very molecules that could warn the planet again. Scientists avoided such language in their official reports, but the poetic symmetry was undeniable. As October drew closer, observatories worldwide coordinated campaigns of near-continuous monitoring. The European Southern Observatory devoted nights on its giant telescopes in Chile to dissecting the comet's chemistry. Infrared observatories scanned for heat signatures that might betray internal activity within the nucleus, while arrays of radio dishes tuned themselves to catch the faintest whispers of unusual emissions. Nothing artificial ever emerged. No coded signals, no pulses from deep space engineering. But the silence itself did not diminish the intrigue. The trajectory calculations had by now refined to astonishing accuracy. 3. I-Atlas would not deviate toward Earth, nor toward Mars itself, but the proximity remained striking. 28 to 30 million kilometers may be vast to human intuition, but on the scale of planetary orbits, it was a hair's breadth. To imagine an interstellar object, one of only 3 ever observed, sweeping through the solar system in such a path precisely as humanity uncovered its strongest Martian biosignatures, was to stand on the precipice of wonder and dread. Some scientists allowed themselves private speculation. If a civilization somewhere had the technology to nudge comets across light years, would this not be the method? Natural-looking, indistinguishable from the random chaos of space, yet carrying precisely the chemistry a barren world requires. Others cautioned against anthropocentrism, reminding colleagues that the cosmos is littered with coincidences and that patterns are a human tendency rather than a universal truth. Still, late-night conferences buzzed with nervous excitement. On Earth, the story began leaking into the public consciousness. News outlets seized on the dual narrative, possible life signs in ancient Martian rocks, and an interstellar visitor with a chemistry that mirrored Mars's atmospheric needs. Social media turned the coincidence into conspiracy. Was Atlas a seed, a terraforming tool, a probe disguised as ice? Memes, debates, and arguments flooded platforms, while official agencies maintained careful restraint. Nothing in the data suggested anything beyond a natural comet, they repeated, though even their measured tone hinted at the magnitude of the mystery. By mid-September, the comet's activity intensified. Its tail extended nearly 10 million kilometers, a river of gas and dust illuminated by sunlight. Instruments detected fluctuations in outgassing rates, as if interior pockets were erupting unpredictably. Some researchers suggested rotational effects. Perhaps the nucleus was tumbling, exposing new layers of volatile ice. Others wondered whether the strange chemistry was driving unstable reactions within. The presence of cyanide compounds added a chilling edge. Harmless in the vacuum of space, they nonetheless carried symbolic weight, reminding humanity of their dual role in both life's origins and its potential destruction. Mars, meanwhile, presented its familiar silent face. From orbit, satellites captured images of dust storms unfurling across its deserts, veiling craters and plains. The rovers below endured the dimming sunlight, their instruments humming steadily as they drilled, sampled, and analyzed. Somewhere beneath those ochre skies, 3.5 billion years ago, microbial mats may have flourished along the deltas of Jezero. Today, their possible fossils lay locked in stone, awaiting human hands to bring them back to Earth. And above, across the gulf of millions of kilometers, a green-glowing traveler whispered down its trail of carbon dioxide as though mocking the planet's present silence with a memory of its fertile past. The alignment was not simply visual or narrative, it was physical. Mars and the comet would share a sector of orbital space within days of one another. Although separated by millions of kilometers, their motions intertwined in a choreography written billions of years ago. Computer simulations showed the comet's tail extending in Mars's direction, though any direct interaction would be negligible. Still, the symbolism was unavoidable. Mars bathed in a faint drizzle of interstellar molecules, its future potentially brushed by the chemistry of another star system. As October approached, scientists began releasing preliminary models of what such an encounter might mean. In practice, the comet's gases would disperse quickly into the solar wind, offering Mars no tangible benefit. Yet models suggested that over astronomical timescales, countless such flybys could cumulatively enrich a planet's atmosphere, seeding it with carbon, nitrogen, and water. Perhaps, some mused, life itself required such wanderers, delivering key ingredients across interstellar gulfs. If that were true, then 3I Atlas was less an anomaly and more a glimpse into the universal machinery that writes biology into stone and soil. The narrative pressed on with mounting suspense. Each new spectral reading teased out more complexity, revealing a molecular library more intricate than anyone expected. Methanol, formaldehyde, and faint traces of hydrocarbons danced among the stronger signatures of carbon dioxide and monoxide. In those fragile molecules lay echoes of prebiotic chemistry, the same ingredients that may have seeded Earth's earliest oceans. To see them here, in such abundance, was to recognize a kinship between star systems. The materials of life, it seemed, were not rare jewels but common threads woven throughout the cosmos. And still the question would not die. Why now? Why Mars? Why this improbable sequence of discoveries converging within months of each other? Astronomers kept their language cautious, but the undercurrent was electric. Each passing night, the comet grew brighter, the data richer, and the sense of participating in something momentous more profound. Humanity stood on the edge of revelation, watching as a messenger from the stars prepared to sweep past the very world where we longed to find life. Imagine a simple act we've all experienced, throwing a ball straight up into the air. At first, the ball rushes upward, fighting against Earth's pull. Gradually it slows, comes to a momentary halt at its highest point, and then inevitably, it begins its fall back down. Gravity always wins, reclaiming what tried to escape. Now imagine throwing that same ball with such tremendous force that it never falls back to Earth. It slips free of our planet's grip entirely, racing away into the vastness of space, never to return. That single act of breaking loose from the pull of gravity is the essence of a hyperbolic orbit. On the cosmic scale, it is the story of escape, of traveling so fast and so far that no celestial body can ever pull you back. Astronomers measure this phenomenon with a number called eccentricity. Orbits that are perfectly circular have an eccentricity of 0, a state of flawless balance. Most planets, including Earth, don't move in perfect circles but rather in gentle ovals. Earth's path, for instance, carries an eccentricity of about 0.017, only slightly off from perfection. Yet when eccentricity rises above 1, everything changes. The orbit ceases to be bound. Instead, the object is on an escape trajectory, one that carries it away from its parent star forever. It is not returning, not looping back, it is leaving for good. That's exactly what defines the object known as 3I/Atlas. Its eccentricity is well above 1, making it undeniably interstellar. It did not form here, and it does not belong here. It is passing through, a traveler from another star system that happened to cross our path. This makes 3I/Atlas only the third confirmed visitor from beyond our solar system, following in the footsteps of the enigmatic cigar-shaped 1I/Oumuamua, which baffled observers in 2017, and the more traditional comet 2I/Borisov, observed in 2019. Each of these visitors carries with it not just foreign matter, but foreign stories, coded into their chemistry and behavior. And while Borisov behaved like a comet we might expect, icy, dusty, glowing with water vapor, Oumuamua was a puzzle, accelerating mysteriously without explanation, almost as though it had a secret engine. Between those two extremes sits Atlas, and it is precisely this middle ground that makes it so fascinating. Atlas is clearly natural, no geometric shapes, no repeating radio signals, no physics that violates our understanding. But the chemistry it carries tells a story unlike anything in our own solar system. This is where the James Webb Space Telescope, humanity's most powerful eye on the cosmos, enters the stage. Since its discovery, Webb has been turning its golden mirrors toward Atlas, studying every wavelength of light it reflects and emits. What the telescope has seen is nothing short of astonishing. Instead of being dominated by water vapor, as nearly every comet in our solar system is, Atlas's coma, The hazy envelope of gas and dust that surround its nucleus is dominated by carbon dioxide. The ratio of CO2 to H2O is roughly 8 to 1, a staggering figure and among the highest ever recorded. To put this into perspective, imagine a cosmic snowball. That is what most comets are. As they approach the sun, the warmth causes water ice to sublimate, turning into vapor that streams outward along with dust and a few trace gases. This is the classic dirty snowball model, one that has worked for decades. But Atlas is no snowball. It is more like a block of dry ice, exhaling carbon dioxide as it warms, sending plumes of it into space while water hides, silent and suppressed. This single chemical fact sends shockwaves through our assumptions. Perhaps Atlas formed in a region of its home system where temperatures were perfect for CO2 to freeze solid while water remained in gas form. That would mean its birthplace was unlike anything in our solar system, positioned near the carbon dioxide ice line of its parent star. Or maybe Atlas's surface has been sculpted by millions of years of cosmic radiation during its interstellar journey, leaving behind a carbon-rich crust that releases CO2 preferentially when heated. Another possibility is selective sublimation. If the outer layers of the nucleus are coated with carbon dioxide ice, then as the sun heats it, that layer sublimates first, masking the presence of deeper water ice. The picture may change as it continues inward, peeling back layers of frozen history, each one whispering clues about its origin. Recent observations only deepen the mystery. Alongside CO2, scientists have detected carbon monoxide, carbonyl sulfide, and buried reservoirs of water ice beneath the surface. These compounds add complexity to an already puzzling chemical mix, and each new detection expands the sense that Atlas is not simply foreign but profoundly alien in its makeup. The Sphere-X Space Telescope, with its powerful infrared sensors, has confirmed these measurements independently, strengthening the credibility of findings that at first seemed unbelievable. And then there is the glow. In September, observers on Earth reported seeing a distinct emerald tint in Atlas's coma. The green glow is usually a sign of dicarbon molecules, two carbon atoms bonded together, or perhaps cyanide compounds. Neither is exotic in cometary science, but their abundance in an interstellar visitor raises profound questions about the chemistry of stellar nurseries far from our sun. It's as though Atlas is carrying a sample of chemical recipes written in another cosmic kitchen, ingredients we've rarely seen combined in such ways. The comparisons to Oumuamua and Borisov are inevitable. Oumuamua, strange and silent, defied explanation, even accelerating mysteriously as if nudged by something unseen. Borisov, by contrast, was a picture of familiarity, dust, gas, predictable jets of vapor. Atlas straddles these two, natural and chemical, but exotic in ways that force astronomers to rethink what they know. NASA and ESA scientists have been quick to push back against viral theories of alien artifacts. Dr. Alan Fitzsimmons of Queen's University Belfast emphasized that while Atlas's composition is unusual, every observation so far remains consistent with natural processes. No repeating radio patterns, no engineered shapes, no impossible accelerations, just chemistry that stretches the boundaries of our imagination, but chemistry nonetheless. Yet there are limits to what we can know. Spectroscopy, the science of decoding light, is delicate. Early measurements are vulnerable to contamination from dust, distortion from Earth's atmosphere, and the changing distance of the comet as it races past us. Ratios can evolve dramatically as sunlight penetrates deeper layers of ice. What looks like a CO2-dominated comet now may reveal a more complex story later, as subsurface water reservoirs erupt into space. The challenge is immense. Astronomers are trying to analyze a moving chemistry set traveling at 30 kilometers per second, tens of millions of miles away, through the filter of telescopes. That we can detect anything at all is remarkable. That what we detect challenges everything we thought we understood about interstellar chemistry is unsettling. As Atlas continues its trajectory, drawing closer to the sun and sweeping past Mars, its anomalies take on added weight. Carbon dioxide is not just a curious component here on Earth. It is the dominant gas in the Martian atmosphere, a greenhouse agent that once supported a thicker, potentially habitable climate on the red planet. If someone, hypothetically, wanted to reawaken Mars, nudging it back toward warmth and habitability, carbon dioxide would be the perfect tool. It is tempting to imagine cosmic coincidences as cosmic intentions. But speculation aside, for now we are dealing with chemistry that is strange but possible, timing that is curious but coincidental, and a trajectory that is carrying this comet within striking distance of a planet humanity has long dreamed of colonizing. The truth is both simple and profound. We are witnessing an interstellar traveler that challenges our models, redefines our expectations, and reminds us that the universe is vast enough to defy our rules. Each observation adds a layer, each spectrum a clue, each detection a whisper of another world. As Atlas passes through our neighborhood, it carries the chemistry of distant stars, the history of alien ice lines, and perhaps the seeds of stories we have yet to imagine. Throwing a ball straight up into the air may seem like a simple playground act, but it hides within it the most profound principle of orbital mechanics. The ball fights against gravity, slows, hovers briefly at its peak, and then succumbs, falling back to Earth. But if you could throw that ball with unimaginable force, enough to break free from gravity's grasp, it would never return. It would escape, traveling outward, never again bound to the Earth that once claimed it. That is the essence of hyperbolic motion, escape written into the very mathematics of orbits. When eccentricity climbs beyond one, the object is no longer a prisoner of a star or planet. It is a wanderer destined to travel endlessly into the cosmic dark. This is the language in which the universe tells us that Atlas does not belong here. Its eccentricity, measured with exquisite precision, is not just above one, but significantly so. No comet born of our solar system could achieve this path. The gravity of our sun cannot bend it into an ellipse. Instead, Atlas will sail on, visiting Mars, brushing near the warmth of our sun, and then vanishing back into interstellar space. It is a visitor, not a resident, a piece of matter carrying with it the fingerprint of another star system's history. This reality places it in rare company. Before Atlas, only 2 such objects had ever been confirmed. Oumuamua in 2017 stunned the world with its strange, elongated form and inexplicable acceleration, behavior so odd that whispers of artificial design circulated among scientists and conspiracy theorists alike. Then came Borisov in 2019, a comet whose behavior was entirely natural, producing water vapor, dust, and carbon monoxide in familiar ratios. Borisov reassured us that interstellar objects could resemble the icy wanderers we already knew. But Atlas sits uneasily between those two. It behaves like a comet, it looks like a comet, and yet its chemistry whispers of something foreign, almost alien. The James Webb Space Telescope was the first to turn its unblinking eye toward Atlas, peeling back layers of starlight to reveal its secrets. The data startled astronomers. Instead of the usual signature dominated by water vapor, Atlas exhaled carbon dioxide in overwhelming abundance. The CO2 to H2O ratio was measured at 8:1, one of the highest ratios ever seen in any comet. This discovery was not an anomaly in the sense of error. It was confirmed independently by SphereX, another space observatory tuned to infrared light. The message was clear. Atlas was not like anything born under our sun. What could explain such chemistry? One possibility is that Atlas formed in a distant region of its original stellar nursery, beyond the point where carbon dioxide freezes solid but where water ice could not survive. Our solar system has such ice lines, invisible boundaries where different compounds condense into solid form depending on the distance from the star. But the balance required for CO2 to dominate so thoroughly, while water remains scarce, suggests a stellar nursery with conditions not mirrored in our own. Another possibility is that Atlas has spent millions of years traveling through interstellar space, bombarded by cosmic rays. Over time, this relentless radiation could have altered its chemistry, creating a crust enriched with carbon compounds that now vent carbon dioxide preferentially when warmed. As Atlas drew closer to our sun, new features emerged. Buried beneath the carbon dioxide surface, faint signatures of carbon monoxide, carbonyl sulfide, and water ice were detected. These findings complicate the picture. Atlas may not be a dry ice monolith, but rather a layered relic, each stratum preserving a different chapter of its history. Perhaps its surface crust masks deeper water reservoirs, waiting for sunlight to dig in and unleash them. Watching this comet evolve as it sweeps toward the inner solar system is like turning the pages of a book written in frozen gas. Then came the glow. In September, ground-based telescopes reported an emerald sheen in Atlas's coma. The green light is often associated with dicarbon molecules or cyanide compounds, substances that form when sunlight breaks down more complex carbon-bearing molecules. While these molecules are not exotic in themselves, their presence in such abundance in an interstellar object raises questions. Where did this chemistry originate? What star forged these compounds? And in what kind of stellar nursery were they assembled? For astronomers, the green glow was not just a visual spectacle. It was a reminder that this comet is carrying the chemical history of another world, perhaps even another kind of solar system. The parallels to Oumuamua inevitably returned. Oumuamua had no coma at all, no gases, no dust, only mysterious acceleration and a strange shape that made it look like nothing we had ever seen before. Borisov, by contrast, could have been mistaken for a solar system comet if not for its trajectory. Atlas bridges them, undeniably cometary, but chemically exotic. It sits in that narrow, fascinating space between the familiar and the profoundly alien. Scientists have been careful in their language, aware of how quickly speculation can spiral into fantastical theories. NASA has emphasized that Atlas remains consistent with natural explanations. Dr. Alan Fitzsimmons, one of the leading experts in interstellar visitors, reminded the public that despite its strange chemistry, Atlas shows no signs of artificial design. No radio transmissions, no unnatural maneuvers, no geometrical perfection in its shape. It is natural. But natural does not mean ordinary. Natural does not mean unremarkable. And yet, even with all the data, uncertainties loom large. Spectroscopic measurements, for all their power, are fragile. Dust can obscure results. Distance warps accuracy. Ratios shift as sunlight penetrates deeper, melting fresh reservoirs of ice and changing the balance of gases. What astronomers are trying to do is akin to analyzing the scent of a perfume bottle from hundreds of millions of miles away, while the bottle is hurtling through space at 30 kilometers per second. That we detect anything at all is a triumph of human technology. That what we detect pushes the boundaries of our models is a humbling reminder of how little we know. The more scientists watched, the more the coincidences piled up. Atlas's chemistry alone would have been fascinating. But its timing makes it something more. While NASA was announcing strong potential biosignatures from Mars, evidence that life might once have taken hold in Jezero Crater, Atlas was already racing toward a close pass of the red planet. The coincidence seemed almost orchestrated. The universe rarely arranges such narratives, yet here is a comet exhaling carbon dioxide, the very gas that dominates Mars's thin atmosphere, arriving just as the world's attention shifted toward Martian life. The haunting question rises naturally. What is Atlas doing here, now, and why is its path carrying it so near Mars? There is no evidence of intention, no reason to assume design. Yet patterns like this, when they emerge, are hard to ignore. If someone wanted to begin the long, slow process of nudging Mars back toward habitability, sending a comet rich in carbon dioxide would be an elegant way to start. Of course, this is speculation piled on coincidence. But the speculation lingers because the timing is so unnerving, the chemistry so perfectly matched to the needs of a dying planet. Atlas does not threaten Earth. It will not strike us, will not rain fire or ice on our world. But it will come within 30 million kilometers of Mars, and in that pass, it may see the planet's atmosphere with its gases. Whether this is accident, coincidence, or something more, it is unfolding in front of us right now. And that is why astronomers cannot sleep. It is not the alien theories, not the whispers of probes or artifacts. It is the timing. It is the chemistry. It is the quiet possibility that the universe has delivered a message in the form of a comet. The path taken by those who sought to reshape the world in their own vision was not a straight one, but rather a journey filled with contradictions, temptations, and dark ambitions that often blurred the line between power and ruin. By the time their movement reached its third stage, the patterns of obsession had already begun to carve deep scars into their story. It was no longer only about survival or even influence. It became about the intoxication of control, the dangerous allure of bending entire societies under a single will, and the quiet yet corrosive compromises that transformed individuals into instruments of an idea far greater and far more merciless than themselves. Here, they discovered that true dominance did not come merely from armies or wealth, but from the ability to weave illusions that people would willingly inhabit, illusions that would become indistinguishable from reality itself. In this phase, their focus turned toward reimagining not only the structures of governance, but also the very perception of truth. The power they craved could not be secured by force alone, because force inspires resistance. Instead, they realized it could be nurtured by shaping belief, by crafting stories so convincing that even the most skeptical would question their doubts. They understood that men and women were guided less by cold reason than by the weight of shared myths, the warmth of belonging, and the fear of exclusion. And so, rather than striking openly, they slipped into the hidden chambers of thought, planting seeds that would quietly bloom in the hearts of millions. What had once been external battles with enemies became internal wars of the mind, fought in silence, often without victims even realizing they had been conquered. The leaders of this movement had grown wise in the psychology of masses. They experimented with spectacle and shadow, with ceremonies that seemed grand yet subtle enough to draw followers into their spell. Torchlight gatherings, music heavy with rhythm, symbols carved into banners. All these became more than decoration. They became instruments of hypnosis, rituals through which people surrendered their skepticism and found themselves swept into tides of belonging. Each repetition of the chant, each coordinated gesture, erased individuality and replaced it with a shared identity, one that bound them closer to the cause and to its architect. The further they marched into this stage, the more they learned how fragile human resistance truly was when faced with the promise of certainty in an uncertain world. Yet, beneath this surface of triumph, the shadows grew longer. The very techniques that granted them power began to consume them as well. To bend others, they themselves had to submit to the machinery of illusion, until it became difficult to distinguish between the manipulator and the manipulated. Their public faces were masks polished to perfection, but in private, fractures appeared. They feared betrayal, they feared exposure, and they feared that their elaborate stage would one day collapse under its own weight. But fear, too, can be a powerful motivator. It drove them to double down on their control, to silence dissent not only with punishment but with erasure. Enemies did not simply disappear. Their names were wiped, their contributions forgotten, their very existence rewritten. History itself became clay in their hands, molded to fit the needs of the present. As their influence expanded, entire institutions bent under their will. Schools no longer taught knowledge for its own sake, but rather molded children into carriers of the doctrine, shaping their innocence into loyalty. Art was no longer free, but turned into propaganda, beauty chained to utility. Even faith, which once offered refuge from earthly power, was forced into alignment with their vision, its sacred symbols appropriated and remade into tools of earthly dominion. And the people, caught between admiration and fear, learned to nod along, even when doubts burned inside them. In the silence of their homes, some whispered to themselves that this could not last, but in the roar of the public square, those whispers were drowned by the deafening chorus of allegiance. But the heart of this stage was not merely external transformation. It was the deepening of a psychological pact. The leaders and the led became bound by complicity. The rulers demanded not just obedience but participation, requiring each individual to carry a share of the burden of the lie. In doing so, they made retreat nearly impossible. To confess doubt was not only to betray the movement, but to confront one's own role in sustaining its cruelty. Thus, people clung more tightly to the very illusions that imprisoned them, for to admit error would be too painful, too humiliating, too dangerous. It was this paradox that solidified the regime more than weapons or armies ever could. The chains were not on their hands, but on their minds. As this cycle repeated, the leaders themselves began to drift into a realm where reality no longer bound them. Surrounded by echo chambers of praise, insulated from contradiction, they came to believe in the myths they had once crafted merely as tools. The lie became truth, even for those who had forged it. In their grand halls, beneath the heavy symbols of authority, they spoke not of strategy, but of destiny. They saw themselves as chosen, as instruments of history, as figures who could reshape the very fabric of human civilization. Their eyes, once sharp with calculation, grew clouded with conviction, and in that conviction lay the seeds of both their greatest triumphs and their inevitable downfall. What unfolded in this stage was both awe-inspiring and terrifying. Whole generations grew under the weight of this system, children who knew no other reality, who absorbed loyalty before they learned independence. To them, the order of things seemed natural, eternal, unquestionable. Streets were filled with parades of flags, skies lit by orchestrated celebrations, voices harmonized in chants that echoed like thunder through the cities. And yet, behind every smile painted for the crowds lay unspoken exhaustion, an awareness buried so deep it could not be named. For while the system appeared invincible, it was built on a fragile foundation, the silence of millions, each one suppressing doubts they dared not articulate. The third step was therefore not merely an expansion of control, but an entrenchment of illusion, a vast theater in which the roles of actors and audience blurred until none could remember where the performance ended and reality began. It was a stage of grandeur and deceit, of confidence and paranoia, of vision and blindness. Those who orchestrated it believed they were building a monument to eternity, yet unknowingly they were constructing a cage, not only for their people, but for themselves. And in the distant echoes of their triumph, one could already hear the faint whisper of collapse, the sound of truth patiently waiting, biding its time, ready to resurface when the stage grew too heavy to hold the weight of its own lies. By the time the journey reached its final stage, everything that had been carefully built in secrecy, then displayed in spectacle and later entrenched through illusions, began to reveal its deepest contradictions. What appeared outwardly as an age of strength was, in truth, an age trembling under its own weight. The leaders had crafted their empire of shadows so convincingly that even they could no longer separate the mask from the face. Yet illusions, no matter how powerful, cannot resist time forever. The fourth stage was the slow unraveling, the echo of truths suppressed for too long, and the reckoning with the very forces they had unleashed to secure their dominion. At first, it did not look like collapse. On the surface, the banners still waved in the wind, the songs of loyalty still echoed through the squares, and the rituals of obedience continued as if nothing had changed. The process of decay begins quietly, like cracks spreading through the foundation of a mighty tower, invisible until the day they can no longer be hidden. Small failures emerged, supplies that did not arrive, speeches that rang hollow, promises that could not be fulfilled. The people who once swallowed lies with ease began to choke on them. Whispers multiplied, and though fear still kept mouths closed in public, in private the silence turned heavy, restless, electric. It was as if an entire nation was holding its breath, waiting for a storm no one dared to name. The rulers sensed the shift, but their response was the same as it had always been: tighten control, demand louder loyalty, enforce harsher punishments. But control, when stretched beyond its natural limits, becomes brittle. Every display of power that once awed the masses now looked desperate, as though the grand stage show could no longer mask the emptiness behind the curtains. The very instruments that had secured their rule, propaganda, surveillance, punishment, now began to corrode the trust of those forced to live under them. People grew weary of chants that no longer inspired, of ceremonies that felt hollow, of leaders who looked less like visionaries and more like prisoners of their own myths. In this stage, paranoia consumed the inner circle. The leaders who once spoke with certainty now quarreled in shadows, fearing betrayal from their own allies more than from their enemies. Every gesture, every word, every silence was examined for signs of disloyalty. Purges followed purges, until the movement that had once been united by conviction became fractured by suspicion. What had begun as a powerful force of destiny now rotted from within, eaten alive by mistrust. The architects of the illusion found themselves trapped in the very machinery they had designed, unable to stop feeding the beast of fear that demanded constant sacrifice. But the greatest betrayal did not come from within the ruling circle. It came from reality itself. For years, truth had been silenced, history rewritten, and facts reshaped to fit the narrative. Yet truth has a strange endurance. It does not vanish but waits, quiet, patient, wearing down the lies like water wearing down stone. And when it returned, it did not come as a whisper, but as a flood. Economic failures, military defeats, social unrest. All of these exposed the hollowness of the grand illusion. Suddenly, the myths that had seemed eternal were revealed to be fragile performances, and the people who once applauded began to see the strings, the cracks in the stage, the exhaustion in the actors' faces. The unraveling was not a single dramatic collapse, but a slow erosion, each moment chipping away at the facade until nothing remained but ruins of belief. The leaders tried to conjure new enemies, new spectacles, new illusions, but their magic no longer worked. The chants were quieter, the parades thinner, the applause hesitant. Even fear lost its grip. For once enough people lose faith, punishment no longer terrifies. It only deepens resentment. The silence of the crowd, once a sign of obedience, became a weapon of resistance. Where once thousands shouted in unison, now they stared blankly, their stillness louder than any protest. And so the movement that had risen from shadows and reshaped entire societies began to crumble, not in fire and blood alone, but in disillusionment. The people who had been trapped within its illusions for so long awoke to the reality of their own complicity. They realized that the chains which had bound them were not made of iron, but of belief, and once belief snapped, the chains fell away. Yet freedom did not come with triumph. It came with confusion, with a painful recognition of years lost, of lives broken, of truths buried. The aftermath of illusion is never simple. It leaves scars that linger for generations. For the rulers, the final act was isolation. Surrounded by walls of their own making, stripped of genuine allies, they faced the mirror they had avoided for so long. Some clung desperately to their myths until the very end, convinced that destiny would still save them. Others, in their last moments, glimpsed the emptiness of their empire, recognizing too late that they had built nothing enduring, only shadows that vanished with the dawn. Their downfall was not just political, but existential. They were consumed by the very illusions that had once made them powerful. The fourth stage, then, was not merely collapse, it was exposure. The masks were torn away, the lies laid bare, the machinery of control revealed as rusted and hollow. And in that exposure lay both tragedy and possibility. Tragedy, because so much had been destroyed in the pursuit of an impossible vision. Possibility, because in the ruins of illusion, truth could finally breathe again. The story did not end with fireworks of victory, but with a weary exhale of a society waking from a long, terrible dream, uncertain of what the future held, but certain of one thing, that no illusion, however grand, can last forever. The moon has always been the closest celestial companion to Earth, near in cosmic terms yet still far enough to remain untouchable, a reminder that proximity does not always equal intimacy. But then, in the vast sweep of the solar system, another story begins to take shape, a story that feels almost like it was written for cinema. Just as the interstellar comet known as 3I Atlas makes its closest approach to Mars, the Earth itself will be blind to its movement. This is not because of distance, but because of alignment, because of an astronomical circumstance called solar conjunction. For several weeks in late September through late October, the object will pass behind the blinding brilliance of the sun, hidden from Earth's most powerful telescopes, as though a whisper drowned out by the roar of a cosmic symphony. At the very moment when its presence near Mars could mean the most for science, it will vanish from our sight, cloaked by the timing of the heavens. The sense of dramatic timing is uncanny, almost scripted. Maximum proximity to Mars coincides with maximum invisibility from Earth, as though some celestial playwright had arranged for secrecy at the very point of greatest significance. And as 3I Atlas continues its journey, it will reach perihelion, the moment of closest approach to the Sun, on October 29th or 30th, positioning itself just inside the orbit of Mars at approximately 1.4 astronomical units from the star that powers our solar system. That placement matters. It puts the comet into the perfect zone for heating, a place where solar radiation will drive outgassing at peak levels, transforming its surface and releasing the chemistry that it has carried from another star system. And yet, all of this will happen tantalizingly close to Mars, a planet that itself remains at the center of scientific intrigue. We won't be left completely blind. While Earth-based telescopes are rendered useless by the glare of the sun, the European Space Agency has prepared its assets in Martian orbit to seize this opportunity. Mars Express, a workhorse spacecraft that has been circling the red planet since 2003, and the Trace Gas Orbiter, operational since 2016 with its mission to study atmospheric chemistry, are both set to observe the comet's passage. These machines represent humanity's only eyes during those hidden weeks. And what they might see raises the stakes to extraordinary heights. They may capture high-resolution imaging of the comet's nucleus, details too fine for Earth-bound telescopes to discern. They may scan with ultraviolet and infrared spectrometers, revealing spectral fingerprints of volatile compounds, cyanide, carbon monoxide, carbon dioxide, each molecule a clue about the chemistry of interstellar nurseries. Dust analyzers may even intercept particles from the comet's tail, giving us direct samples of matter forged around distant suns and carried across the cosmic void to our doorstep. The scientific payoff of such an encounter is immense. This is not just another comet. This is only the third confirmed interstellar visitor in history, a piece of another star system wandering into ours. 3. Atlas gives us a rare data point, a chance to compare how chemistry unfolds around alien suns compared to our own. Already, early spectroscopic measurements suggest an unusually high content of carbon dioxide, a ratio far beyond what we typically see in comets native to our solar system. That peculiarity is more than trivia. It could reveal new pathways of planet formation in distant stellar nurseries, processes that might differ from those that shaped Earth, Jupiter, and Mars. The story is not only about a comet, but about cosmic origins themselves. And then, as though the universe wanted to stir our imagination even further, Mars itself enters the frame. Recent discoveries in Jezero Crater have reignited the debate about biosignatures, potential chemical markers of ancient microbial life. Mars today is a dry, cold desert. Its thin atmosphere, composed of 95% carbon dioxide, a fragile remnant of what was once a thicker, more protective veil. Billions of years ago, rivers carved channels across its surface, lakes filled craters, and water moved freely under skies that were dense enough to shield liquid from evaporation. But over eons, the atmosphere was stripped away, blown into space by the relentless solar wind, its magnetosphere too weak to defend it. Mars became what it is today, a ghost of a once habitable world. So what happens when a carbon dioxide-rich comet, carrying precisely the molecules Mars would need to rebuild its atmosphere, sweeps past the red planet at the very moment we are re-examining its potential for life? The timing feels too coincidental to ignore. The rational voice insists on perspective. One comet is not enough. Even a comet loaded with volatiles is a mere cup of water tossed into an empty swimming pool. It cannot restore what has been lost over billions of years. Mars will not suddenly regain its oceans or atmosphere from the passing of 3I Atlas. And yet, the imagination whispers another question. What if this is only one delivery among many? What if interstellar comets are part of a larger, longer process of atmospheric replenishment, a cosmic mechanism to maintain habitable conditions across planets? The comforting news is that Earth itself faces no danger. The comet's trajectory keeps it at a safe distance. Its closest pass to our planet won't occur until mid-December, and even then it will be a vast 1.8 astronomical units away, about 168 million kilometers, farther even than the Sun. That's safer than the solar radiation we receive every day. But safety does not diminish the strangeness of the geometry. An interstellar visitor, rich in carbon dioxide, the very gas Mars needs most, arrives at the moment of renewed excitement about Martian life, passes in secrecy while Earth looks away, and departs having delivered its mystery in full. If you wrote this into a film, critics would dismiss it as contrived. And yet the universe has no editor. The timing is what it is. When Earth-based observation resumes in November and December, we may be looking at an entirely transformed object. The perihelion passage will bake its surface, drive away volatiles, and perhaps reveal its core. Its coma and tail may change shape and chemistry, altering the very identity of the comet we thought we knew. The European Space Agency has been frank about the challenges. This is not an object we can chase with a spacecraft. Its velocity and trajectory make intercept impossible with today's technology. We must content ourselves with the glimpses afforded by orbital telescopes and the data captured by the probes at Mars. Sometimes, in the vast theater of space, we are not actors but audience, watching a drama unfold at a scale we cannot touch. And perhaps that is appropriate. Not every question is meant to be answered, not every mystery unraveled. As 3I Atlas races toward its silent appointment with Mars, we are left to wonder what story it carries in its frozen nucleus, what secrets of distant suns lie within its volatile plumes. The orbital mechanics are simple enough, the physics straightforward. But the timing, the chemistry, the coincidence, they remain uncanny, as though the universe were whispering in a language just beyond our comprehension. The comet was never meant to belong here. Its chemistry, its trajectory, even its sheer speed all testify to an origin beyond our own solar nursery. It comes from a place where the rules of formation may have played out differently, where the balance of elements and volatiles might not resemble the pattern we take for granted in our system. That alien fingerprint becomes most striking when astronomers turn their spectrographs toward it and see ratios that defy expectation. A surplus of carbon dioxide, a deficit of cyanide, an imbalance that whispers of another kind of cradle, another kind of sun. It is as though the comet carries in its frozen heart the memory of a star that no longer shines, of a molecular cloud that collapsed far from ours, where the chemistry of life may have written itself in a different dialect. The knowledge of that alien chemistry alone would be enough to justify the feverish excitement among scientists, but the cosmic stage offers more than just a chemical oddity. The comet is not passing quietly through the void. It is threading its way near Mars, the one planet in our system that hovers perpetually on the boundary between death and potential life. That juxtaposition is almost theatrical. An interstellar body, still carrying the volatile ices of its birth, comes closest not to Earth, not to Jupiter, but to Mars, a world once alive with rivers and rain, now frozen beneath a frail sky. To scientists, it feels like a conversation between two worlds, one delivering raw material, the other holding scars of an atmosphere long since stripped away. Every spacecraft circling Mars is being repurposed to turn its instruments toward this visitor. The Trace Gas Orbiter, originally designed to sniff the faintest traces of methane above the Martian surface, now becomes a tool for interstellar chemistry, its sensitive detectors ready to capture the spectral glow of outgassing ices as the comet draws near. Mars Express, ancient by spacecraft standards but still resilient, will contribute its eyes and ears, its cameras and spectrometers aimed outward instead of downward. These machines become humanity's ambassadors, silent witnesses posted at the crossroads of a planetary orbit and a comet's arc. In their data will be written stories that no telescope on Earth could have captured, for our own planet is blinded by the sun at the very moment that matters most. It is as though Mars has been granted exclusivity, a private audience with a traveler while Earth waits in ignorance. That audience could reveal things no laboratory on Earth has ever seen. When comets pass close to planets, dust sometimes showers down, fine grains of rock and ice falling through thin atmospheres. On Earth, such dust often burns into meteors. On Mars, with its whisper-thin sky, particles might reach the ground intact, leaving microscopic traces scattered across the regolith. The idea that Mars could quietly accumulate dust from another star system feels almost like science fiction, yet it is entirely plausible. Instruments may not be sensitive enough to track each grain's fall, but the possibility hangs in the air like an unspoken promise. Somewhere in those frozen shards might lie isotopic ratios different from any we know, tiny time capsules of alien chemistry that could outlast even the comet itself. Yet beyond the data, beyond the laboratory precision of measurement, there lingers something harder to define. There is a feeling that timing has meaning, that the comet's approach is not random noise but part of a pattern we cannot yet perceive. For centuries, humans have looked at comets and seen omens, portents of doom or change. Modern science strips away the superstition, replacing it with equations and orbital predictions. And yet, as 3I Atlas approaches Mars while hidden from Earth, even scientists speak of coincidence with an uneasy smile. They know the odds are vast, the alignment improbable, and still the moment feels like narrative rather than chance. On Mars, the traces of a thicker atmosphere remain etched in stone. Valley networks carved by ancient water stretch for hundreds of kilometers. Sedimentary layers rest in crater basins, testifying to lakes that endured for millennia. Even the mineralogy whispers of lost seas, with clays and sulfates forming only in the presence of standing water. Billions of years ago, Mars was no barren wasteland. It was a world of rivers, storms, and perhaps even oceans. What happened to that world is no longer a mystery, but a tragedy. Without a strong magnetic field, the planet's atmosphere was eroded by the solar wind, molecule by molecule stripped away until only a fragile wisp remained. Now, into that desert world drifts a comet carrying the very gases Mars once possessed in abundance. Carbon dioxide, in particular, was once the bulk of the Martian atmosphere, the greenhouse blanket that kept its water liquid. To imagine that same molecule now returning, borne by an interstellar messenger, is to glimpse an echo of restoration. No one suggests Mars could be remade by this single encounter. But imagination refuses to let go of the symbolism. The comet becomes a courier, delivering back to Mars a fragment of what it lost, as if to remind us that planets are not closed systems, that the cosmos itself can contribute to their fates. From Earth's perspective, this entire drama is invisible until November. Our most advanced observatories, our grandest telescopes, will see nothing while the comet makes its closest pass. Only when the solar conjunction ends will it appear again, changed, its coma expanded, its chemistry altered by its brush with the sun. By then, Mars will have borne witness to what we could not, and the spacecraft orbiting it will carry back the only testimony available. It is a humbling thought that with all our technology, all our instruments on Earth, we are dependent on robots circling a distant world to tell us the story of an interstellar traveler. And what story will it be? Perhaps the instruments will confirm the high carbon dioxide ratios, sharpening our models of how interstellar ices form. Perhaps they will reveal isotopes that point to conditions unlike any nebula we have studied, showing us that not all stars forge their comets the way ours does. Perhaps, though less likely, they will capture something entirely unpredicted, new molecules, strange crystalline structures, volatile species never before cataloged. The universe has a way of rewarding curiosity with surprises. And with each new detail, our understanding of planetary birth and cosmic chemistry grows more complex, more textured. Still, beyond the science, there is narrative, and narrative is what draws us as humans. A comet born in another star system enters ours, carrying gases that Mars once relied upon, passing closest to the very world whose lost habitability defines our hopes and fears about life beyond Earth. It does so while hidden from Earth's gaze, seen only by the machines we have stationed around Mars. And when it leaves, it carries with it unanswered questions, leaving us with data but also with wonder. It is hard not to feel that the cosmos has staged this as a performance, not for us but with us watching from the wings. The comet will not linger. Its hyperbolic path ensures it will never return, never orbit, never become part of our solar family. Once perihelion passes, it will arc outward, climbing back into the dark, destined for interstellar space once more. Mars will resume its slow circling of the sun, still barren, still waiting. Earth will continue its daily routines, its telescopes pointed outward again, capturing the last glimpses before the visitor vanishes forever. But the memory will remain. For a brief moment, an alien traveler came close, whispering secrets in a language of ice and gas, secrets that may tell us not only about other worlds but about our own origins as well. Perhaps, in that fleeting moment, Mars and the comet shared something more profound than chemistry. Perhaps they shared a reminder that in the vastness of space, planets and comets, stars and dust are all part of a conversation older than humanity, a dialogue written in elements, in atmospheres, in the fragile conditions that allow life to begin. And as long as we listen, as long as we point our instruments outward and wonder, we remain part of that dialogue too. The comet's departure from the vicinity of Mars did not mark the end of its story, but rather the beginning of an even more extraordinary chapter. As it slipped past the red planet, its path bent only slightly by Mars's weak gravity, it continued its journey inward, ever closer to the blinding heart of the solar system. With each passing day, the sunlight grew more intense, and the fragile ices locked deep within its nucleus began to awaken. Jets of gas erupted from fissures in its surface, spraying dust and vapor into space, building the luminous coma that made it unmistakable even against the backdrop of countless stars. For astronomers, this transformation was no surprise. It was the destiny of every comet that ventured too near the sun. Yet for this one, the interstellar traveler that had already defied expectations, each new observation deepened the mystery rather than resolved it. The chemical composition of its emissions continued to puzzle researchers. While Earth's ground-based observatories were finally able to resume their watch after conjunction, they saw not the familiar fingerprint of native solar system comets, but a spectrum that stubbornly refused to fit the template. Water vapor, yes, and carbon dioxide in startling abundance, but the ratios to other gases defied every model. Cyanide, normally a hallmark of comets in our own system, was nearly absent, while carbon monoxide fluctuated in ways that hinted at subsurface layers releasing their stores unevenly. It was as if the comet's nucleus was stratified not just by temperature, but by a geological history unlike anything born under our sun. Some scientists speculated that the comet might have formed in a region of its parent star's nebula where ultraviolet radiation had altered chemistry in ways we had never seen. Others suggested collisions during its early life could have layered it with alien material. Whatever the cause, the comet seemed determined to remind us that not all worlds are born alike, and that diversity extends even into the frozen debris that sails between the stars. Amid this scientific frenzy, the public fascination with the comet grew exponentially. For centuries, comets had inspired awe and fear, painted in literature as harbingers of change. But this one carried the added allure of otherness. It was not merely a messenger from the outer solar system, but from another star entirely. The thought that dust particles from its tail might eventually settle on Earth filled imaginations with a strange mixture of wonder and unease. Could such alien grains bear new chemistry, perhaps even molecules linked to life? Journalists latched onto the story, and headlines described the comet as a visitor from the deep beyond, a cosmic envoy. Late-night debates questioned whether humanity should attempt to send a mission, some daring robotic probe to chase and study it before it vanished forever. Yet the speed of the comet made such dreams impossible. It moved too swiftly, and our technology, for all its ambition, was not yet prepared to launch such a pursuit on short notice. Still, that limitation did not dim the enthusiasm of those who studied it from afar. Spacecraft around Mars continued to feed back streams of data, while Earth-based observatories, both professional and amateur, filled the internet with images of its brightening coma and streaming tail. Even children, learning of the comet in classrooms, found themselves gazing skyward, wondering about the distances it had traveled. Teachers spoke of interstellar space, of how far a comet must drift to escape its home star, and how unlikely it was to encounter ours. The comet became a symbol of chance encounters in the cosmos, a reminder that while stars and planets obey the mathematics of gravity, randomness still weaves through the tapestry of the universe. As perihelion approached, the comet's closest approach to the Sun, the anticipation reached a fever pitch. Would the interstellar visitor survive its brush with solar fire? Or would it disintegrate into dust, its secrets lost forever? Some comets, fragile and loosely bound, dissolve when they come too near, leaving only a memory in photographs. Others endure, scarred but still intact, to sweep outward again on elongated orbits. But this comet was different. Its hyperbolic trajectory guaranteed it would not remain bound. Whatever happened near the Sun would be the last time humanity would ever see it. The stakes, emotionally if not scientifically, were enormous. Instruments were tuned, telescopes calibrated, spacecraft aligned, all to capture the final act of a drama billions of years in the making. When the comet reached its point of greatest peril, the Sun's radiation turned its coma into a vast, glowing shroud. The tail stretched millions of kilometers, a shimmering veil of dust and ionized gas pushed outward by solar wind. Observatories recorded a spectacle unlike any seen in decades. For a time, it blazed brighter than most stars in the night sky, a beacon visible even to casual stargazers. Its survival became the subject of hourly updates, each new image scrutinized for signs of disintegration. But though fragments broke free and jets flared wildly, the nucleus itself held together. Against the inferno of the Sun's heat, the traveler endured, battered but unbroken. That resilience only added to its mystique, as if it carried within it not only chemistry, but strength born of an alien cradle. As it swung around the Sun and began its outward trajectory, a strange quiet settled over the scientific community. The most dramatic moments were over. What remained was data to be parsed, spectra to be analyzed, theories to be tested against stubborn evidence. Yet even in that quiet, deeper reflection began. What did it mean that humanity had witnessed such a thing? For generations, we have sought to answer the question of whether we are alone, whether life is a rare miracle or a cosmic inevitability. This comet did not answer the question, but it complicated it, broadening the range of what we must consider possible. Its very existence was proof of planetary systems forming differently elsewhere, of chemistry writing new rules under alien suns. If comets can wander between stars, so too can the building blocks of life. And if those building blocks can cross gulfs of light years, perhaps the seeds of life itself are scattered more freely than we dare imagine. In the weeks that followed, scientists met in conferences, papers were drafted, arguments sharpened. Some claimed the comet's carbon dioxide ratios hinted at formation in a colder nebula than ours. Others argued that the absence of cyanide pointed to ultraviolet radiation fields stripping molecules during its birth. Disagreements abounded, but through them ran a current of excitement that no dispute could dampen. They all knew they were living through a moment that future generations of astronomers would reference. This was not merely a comet. It was a messenger that expanded the boundaries of what science could test, a reminder that the universe still had surprises waiting beyond the horizon. For the wider public, the comet's retreat into the dark sky carried a bittersweet note. People who had watched it nightly now faced the knowledge that it would never return, that its glow would fade until it became invisible, a memory written only in photographs and data. Yet that loss only amplified its meaning. Like a fleeting visitor who leaves just enough behind to alter the course of thought, the comet reminded us that encounters with the unknown are often brief but transformative. It became a story parents told their children, that in their lifetime, they had witnessed a messenger from another star blaze across their sky. In such stories, the wonder of science and the poetry of myth merged, carrying the comet's legacy forward. For the comet itself, there was no awareness, no intent, only momentum and physics. Yet in our eyes, it had played the role of a teacher, a catalyst, even a mirror. By studying its alien chemistry, we learn not only about other worlds but about our own assumptions, the blind spots in our models, the biases in our expectations. By watching it survive the sun, we glimpsed resilience beyond what we thought possible. And by seeing it vanish, we remembered the fragility of opportunity, how easily the universe could have hidden this spectacle from us forever. The comet's tail was not just about ice and dust. It was about perspective, about the way a single event can stretch human imagination across light years and epochs. As the traveler faded into the blackness beyond Jupiter's orbit, humanity returned to its routines. Yet something had shifted. Telescopes turned outward with renewed urgency. Searches for the next interstellar visitor intensified. Proposals for faster probes gained traction. The comet had set a challenge, to be ready next time, to meet the cosmos not only with wonder, but with preparation. Somewhere, beyond the veil of stars, other travelers drift, silent and unseen, waiting for their chance encounter with another sun. And when they come, we will remember this one, the first to show us that the universe's pathways are not closed, that even across unimaginable distances, worlds can touch one another through the fragile, fleeting gift of a comet. The comet's outward journey after surviving its perilous encounter with the sun was never going to be a quiet epilogue. Instead, it marked the culmination of everything humanity had felt and feared since the first detection of this wandering stranger. As its orbit carried it past the orbit of Earth, still moving with impossible velocity, the spectacle of its great tail lingered in the sky, a fading reminder of just how fragile and temporary such encounters truly are. Astronomers, armed with terabytes of data, knew this was the final window before the travelers slipped into the darkness, forever beyond reach. Each night became precious, each spectrum, each pixel of imagery treated like a treasure. The comet had survived the sun's furnace. Now it was fleeing, dragging behind it the greatest questions of our age. Even as it grew fainter to the naked eye, the strange chemistry of its emissions refused to let the story end. Deeper layers within its nucleus now began to reveal themselves. Gases that had been trapped for billions of years, sealed away during its long exile between the stars, began to leak into space. Complex organics, molecules that on Earth were associated with biology, showed faint signatures in infrared studies. Polycyclic aromatic hydrocarbons, amino acid precursors, and unfamiliar spectral lines that defied neat categorization danced within the comet's fading light. For a few fevered weeks, arguments erupted in laboratories and conference calls across the globe. Was this proof that alien planetary nurseries naturally brewed the same ingredients that seeded life here? Or were these merely exotic but non-biological chemical processes, reminders that not all organic molecules point to biology? No definitive answer emerged, but the very fact that such debates were even possible electrified the community. Meanwhile, the public, now trained by months of breathless coverage, hung on every new announcement. The comet had become more than a celestial body. It was a cultural phenomenon. Documentaries aired nightly, books were rushed into publication, and artists painted sweeping canvases of the alien visitor blazing across alien skies. Some treated it as an omen, weaving it into prophecies about humanity's future. Others found in it a strange comfort, the idea that the universe was not a closed system but an open sea, where fragments of other worlds could wash upon our shores. For the first time in decades, scientific discovery and popular imagination merged into a single narrative, a story told across disciplines, cultures, and continents. Yet beneath the excitement lay an undercurrent of unease. The comet's proximity to Mars, the coincidence of its timing with the announcement of Martian biosignatures, and the sheer improbability of its trajectory gnawed at even the most disciplined minds. Was it truly random? Could such precision arise naturally? Or was there a hidden architecture to cosmic events that we had not yet deciphered? Some dismissed these thoughts as superstition, but others whispered about panspermia, about the possibility that comets like this one were not merely messengers but gardeners, sowing life as they wandered across starfields. If that were true, then perhaps Mars had once received such a gift. Perhaps Earth itself was the product of such deliveries in deep time. To contemplate this possibility was to stare directly into the origin story of humanity. As the weeks turned to months and the comet retreated past Jupiter's orbit, its brilliance dimmed, but the urgency of study only grew. Instruments stretched to their limits to capture its fading signal. Each data point was treated as a fragment of scripture, something to be pored over, reinterpreted, and argued about for years to come. Graduate students who had barely begun their careers suddenly found themselves co-authors on papers that would define their generation. Veterans of cometary science admitted that this single object had overturned more assumptions than a lifetime of research. No matter where the debates landed, no one could deny that something profound had been witnessed. In the final months of observation, as the comet crossed the threshold beyond Saturn's domain, silence began to settle in. The telescopes that had tracked it nightly now registered only faint traces, a blur against the cosmic background. One by one, observatories declared an end to their campaigns, redirecting their instruments to other targets. The traveler had become a ghost, slipping into the abyss where human eyes could no longer follow. Yet rather than sadness, what remained was a sense of reverence. It had come unannounced, lingered just long enough to upend our expectations, and departed without explanation. Its role was not to answer questions, but to ask better ones, to force us to reconsider what kind of universe we inhabit. What does it mean when a fragment of another star system brushes past your doorstep? It means that boundaries are illusions, that interstellar space is not empty, but alive with exchange. It means that our solar system is not isolated, but part of a galactic ecology where matter and chemistry drift endlessly, seeding, colliding, and transforming. It means that when we look at Earth and Mars and wonder about life, we must widen our gaze to include the possibility that the origins of biology are not confined to any one planet, or even to any one sun. This single comet, blazing briefly across our skies, reminded us that the story of life may be a galactic story, written in dust and ice across countless worlds. And so the narrative closed not with a bang, not with catastrophe or revelation, but with a slow fading into the infinite dark. The comet receded, its tail dwindled, and its coma dissipated, until it was nothing more than a number in a catalog, a set of orbital elements describing a path that would carry it forever outward. Yet in that fading, there was a kind of victory. Humanity had met the unknown and listened. We had gathered data, argued fiercely, dreamed boldly, and above all, remembered that the cosmos does not exist for our convenience. It exists in its own majesty, and we are fortunate when we catch even a glimpse. For those who had watched it closely, there remained a final act of imagination, to picture the comet as it would one day drift into the silence between the stars again, leaving our system just as it had left another before. Perhaps, millions of years from now, another civilization around another sun would detect it, measure its strange chemistry, and marvel as we had. Perhaps they, too, would wonder about the timing, the coincidence, the mystery. And in that moment, across light years and centuries, our experiences would connect, joined by a single fragment of ice and dust that carried with it the shared astonishment of being alive in a universe so vast and so improbable. The interstellar visitor was gone, but its meaning endured. It left us not answers but possibilities, not closure but expansion. It reminded us that chance encounters can change the trajectory of thought forever, and that sometimes the most fleeting visitors leave the deepest impressions. And so humanity turned its eyes once more to the skies, waiting, searching, wondering when the next messenger would arrive, carrying with it the next chapter of the story of the cosmos. The story of human civilization has always been entangled with the forces of the cosmos, and now more than ever, our growing technological reach makes us confront questions once left only to philosophers and dreamers. The DART mission marked a milestone in planetary defense, showing that we now possess the basic technological building blocks of celestial engineering. We can detect hazardous objects that might threaten our world, we can calculate precise orbital trajectories with astonishing accuracy, and we can execute kinetic impact missions that alter the paths of bodies millions of kilometers away. This achievement is not merely a demonstration of raw technology. It is evidence that humanity has begun to engage with the architecture of the cosmos itself. These capabilities, though originally designed to protect Earth, spark imagination about what else might be possible. Could they, in theory, be applied to atmospheric delivery or planetary-scale engineering? The scale of such ambitions would be vastly greater than anything achieved so far, but the seeds of possibility are undeniable. The very thought ties into the deeper allure of cosmic speculation. Ideas like desert supercomputers or buried networks of ancient technology beneath the sands of forgotten landscapes. Testable elements of such hypotheses might include hidden radio signatures, electromagnetic anomalies, or chemical residues in groundwater. Yet, despite increasing searches, none of these have been detected. The tools we develop for science, however, grow more refined with each passing year. LiDAR mapping, satellite-based ground-penetrating radar, and sophisticated geological analysis are pushing back the boundaries of what can remain hidden. With every innovation, the Earth itself becomes a little more transparent, its layers revealing stories once inaccessible. Whether or not such stories include artificial structures or concealed networks, the point remains, the scientific hunt continues, relentless and methodical. At the heart of this curiosity lies something profoundly human, our awareness of fragility. Climate change, nuclear arsenals, artificial intelligence risks, and the looming shadow of asteroid impacts remind us daily that civilization rests on precarious foundations. Against this backdrop, the idea that someone else, some earlier intelligence, may already have solved these challenges feels deeply comforting. It offers the promise that safety nets might already exist, waiting to be revealed. Yet comfort and truth are not the same. The speculative frameworks of quantum archaeology or desert supercomputers might provide metaphors, ways to think about resilience and survival, but they cannot replace the rigor of evidence. The true work of science is quieter and humbler. Instead of grand revelations, we build datasets, collect observations, and search for patterns invisible to earlier generations. Interstellar visitors like the Comet 3 I-Atlas remind us of the scale of this endeavor. Each fragment of data, each chemical signature logged, becomes part of a growing tapestry that may one day reveal answers invisible now. The comet's chemistry could be part of a natural pattern, an echo of interstellar space itself, rather than evidence of concealed machines. The universe owes us no explanations. It provides phenomena, coincidences, and mysteries, but it is our responsibility to maintain curiosity and discipline in the face of the unknown. This is where the idea of the test emerges. Perhaps the real trial posed by 3I Atlas is not its chemistry, its trajectory, or its coincidence with Martian exploration. Perhaps the test is about us, about whether we can maintain scientific curiosity while resisting the allure of packaged answers. The unusual timing and composition of the comet might tempt us to embrace comforting explanations. It is so much easier to believe in deliberate design, in cosmic messages or alien interventions, than to sit in the uncertainty of natural mystery. Yet true transcendence lies in resisting that temptation. The test, then, is not literal. The universe is not a classroom, and comets are not exam papers. Rather, the cosmos constantly presents us with puzzles that force us to confront our assumptions. How we choose to respond, to leap towards certainty, or to walk patiently into complexity, determines our trajectory as a civilization. The same holds true for practical challenges. Can we maintain funding for Mars sample return in the face of politics and budget pressures? Can we sustain survey networks that cost millions but provide the backbone of planetary defense? Can we resist the temptation to turn mysteries into viral spectacle, prioritizing social media engagement over careful analysis? These are not abstract questions. They cut to the heart of policy, governance, and global cooperation. They determine whether humanity develops the capability to recognize and respond to anomalies with clarity rather than confusion. 3I Atlas, with all its strangeness, becomes a mirror reflecting back not only interstellar chemistry, but also our own decision-making. It tests our commitment to evidence-based reasoning, not with a single dramatic moment, but with the slow unfolding of observation and analysis. The DART mission once again provides a model for how to proceed. Faced with the real risk of asteroid impact, humanity did not collapse into fear or dismiss the problem outright. Instead, step by step, we developed the capacity to detect, assess, and intervene. When DART struck its target and successfully altered the orbit of Dimorphos, it proved that patient, disciplined science could achieve outcomes that once seemed impossible. It provided a template, rigorous analysis leading to effective technological response. This evidence-based model stands in stark contrast to the way 3I Atlas has been received in public discourse. When its discovery was announced, social media amplified the most extraordinary claims: alien artifacts, engineered delivery systems, cosmic prophecies. In comparison, sober scientific explanations struggled to gain attention. The signal was drowned in the noise. The algorithms of the digital age reward exaggeration and spectacle, making it increasingly difficult for careful analysis to hold its place in the public imagination. Yet, this imbalance is part of the test. Institutions like NASA have responded with an approach worth noting. They did not mock or dismiss public speculation outright. They did not become entangled in endless arguments with conspiracy theories. Instead, they provided clear, factual updates: what had been observed, what was certain, what was uncertain, and what conclusions the data supported. They acknowledged ambiguity without surrendering to it. They reinforced the principle that extraordinary claims demand extraordinary evidence. This, ultimately, is the challenge of 3I Atlas. Its strange chemistry, its uncanny timing, its dramatic trajectory, all of these invite speculation. But speculation without discipline is a trap. The true measure of our readiness for the cosmos is not whether we can invent stories about comets, but whether we can confront them with patience, rigor, and honesty. The universe is vast, and mysteries will never run out. The question is whether we are ready to face them as scientists, or only as storytellers. 3I Atlas, then, is less about what it is, and more about what it demands of us. Will we choose transcendence, the path of curiosity, discipline, and humility, Or will we settle for packaged solutions that soothe but do not illuminate? That choice, more than the comet itself, will define our legacy. The strange journey of 3I Atlas continues, and as it moves through the inner solar system, the world's observatories have turned toward it in coordinated fashion. This is not a lone telescope chasing a faint speck of light anymore. It is a planetary effort, a chorus of instruments spread across continents and orbits, each contributing a fragment of truth. Professional astronomers, amateur skywatchers, orbital observatories, and even citizen scientists with access to advanced CCD equipment are all participating. Together they form a distributed nervous system for our species, one that tracks, records, and interprets a visitor from beyond the stars. In this way, 3I Atlas has become more than an object of curiosity. It has become a test of our ability to cooperate across borders and institutions in pursuit of knowledge. The transparency of these efforts is as important as the data itself. Open databases update in real time, logs are published with timestamps and calibration notes, and spectral readings are shared with international teams without hesitation. In the past, such openness might have been rare. Space agencies would guard results, waiting for peer-reviewed confirmation before releasing anything. But the stakes here demand immediacy. Scientists recognize that withholding information in such a charged atmosphere would feed conspiracy, not prevent it. By publishing their findings, even with caveats, they demonstrate that science is not about secrecy, but about process. This openness allows anomalies to be cross-checked, potential biases to be identified, and corrections to be made swiftly. It is within this framework that the unusual chemistry of 3I Atlas has been scrutinized again and again. Independent confirmation from the Sphere-X Space Telescope, corroboration from the James Webb, and consistent reports from ground-based arrays strengthen the reliability of what initially appeared to be impossible data. At first, the 8-to-1 ratio of carbon dioxide to water seemed like noise, a fluke, or a calibration error. But with each new reading, the numbers held. What was once unbelievable has hardened into fact, and the scientific community has had to adapt. This adaptation is not smooth or unanimous. Some researchers remain skeptical, others propose new models, and still others urge caution before declaring this the new standard of interstellar chemistry. But such disagreements are the lifeblood of science, not a weakness. Debate sharpens ideas, forces models to evolve, and prevents premature conclusions. What makes this moment significant is not just the comet itself, but the broader philosophical weight it carries. Humanity is confronted with a choice between two postures: transcendence or packaged solutions. Transcendence demands patience, humility, and the acceptance that some mysteries cannot yet be solved. Packaged solutions, on the other hand, offer comfort, easy answers, cosmic narratives, speculative certainties. In times of uncertainty, packaged solutions thrive because they feel safer. They quiet the restless mind. Yet the price of embracing them is stagnation. If we accept the most convenient explanation too quickly, we close the door to deeper discoveries that require time and rigor. The looming Mars flyby heightens this tension. As 3I Atlas moves toward its closest approach to the red planet, speculation has exploded. The alignment seems too neat, too cinematic. The idea of a comet carrying carbon dioxide, a key gas in Mars's climate history, sweeping close to the planet just as robotic missions prepare to study its surface. This feels scripted, deliberate. Online forums and viral videos seize on this coincidence, weaving elaborate theories of terraforming attempts, alien delivery systems, or cosmic warnings. But for scientists, the coincidence is a chance to refine models, not confirm fantasies. The Mars flyby provides an opportunity to observe the comet under different thermal conditions, to test whether its chemistry changes as it absorbs more solar radiation, and to compare those shifts with models of sublimation dynamics. The transparency of preparation for this flyby is remarkable. Agencies have released detailed schedules of observation campaigns, specifying which instruments will be watching and what data they aim to collect. Amateurs are invited to contribute, their observations feeding into aggregated databases that strengthen the collective picture. This inclusion is not merely symbolic. It genuinely increases coverage, ensuring that transient phenomena are not missed during instrument downtimes or weather interruptions. In this way, the comet has become a democratic experiment in science, a shared endeavor that blurs the line between professional and public. As anticipation builds, the frameworks of transcendence and packaged solutions collide more directly. Commentators urge caution, reminding us that coincidences are not evidence, that the human brain is a pattern-seeking engine prone to narrative invention. Others argue that dismissing speculation too forcefully risks alienating the public. That engagement, even through extraordinary ideas, can inspire wonder that ultimately fuels science. This tension is not easily resolved. Both caution and inspiration are needed, but in balance. The lesson of history is that unchecked speculation can lead to delusion, while excessive skepticism can suffocate curiosity. Meanwhile, the comet itself remains indifferent. It does not care about debates or narratives. It simply continues on its hyperbolic path, a fragment of matter shaped by forces older than our species. Its chemistry tells a story of frozen reservoirs and interstellar radiation, of epochs before the Earth even existed. To interpret that story requires not just instruments but perspective. We must remember that the cosmos is vast beyond comprehension, and coincidences will always arise when countless objects trace countless paths across infinite space. That one of these paths happens to intersect symbolically with our own story does not prove intention, it proves scale. Yet the allure of intention remains strong. Some speculate that the universe itself is testing us, offering puzzles to measure our readiness for a broader role in cosmic life. Others reject this framing, insisting that it projects human psychology onto indifferent matter. Still, even those who deny cosmic intention admit that 3i Atlas functions as a test in a practical sense. It tests our instruments, our methods, our cooperation, and our patience. Whether or not the universe intended it, the effect is the same. The next weeks will strain our ability to remain disciplined. Data will flood in, anomalies will appear, and each will tempt immediate interpretation. Social media will amplify the most sensational readings, while sober corrections will lag behind. The question is whether the public, and even the scientific community, can resist the gravitational pull of premature conclusions. The real challenge is not in observing the comet, but in observing ourselves, our biases, our hopes, our fears. Can we stand in the tension of mystery without collapsing into certainty? If we can, then 3i Atlas will have served its purpose, not by delivering answers, but by strengthening our capacity to live in the questions. That capacity, more than any single discovery, may determine our future among the stars. The test is not whether we uncover alien technology or confirm exotic chemistry. The test is whether we can build a civilization that treats the unknown not as a threat or a blank canvas for projection, but as a field for disciplined wonder. If we succeed, then each comet, each anomaly, becomes an invitation to grow. If we fail, then even the brightest discoveries will dissolve into noise. The comet presses onward, its hyperbolic arc slicing through the inner solar system, and every passing day draws it closer to its fateful encounter with Mars. The sense of inevitability grows heavier. It is not simply an astronomical curiosity anymore. It has become a narrative woven into human culture. News outlets dramatize its approach. Documentaries rehash every known detail. Artists sketch surreal visions of the red planet wrapped in a carbon dioxide haze. What began as a technical announcement buried in astrophysical journals has become a story retold around dinner tables and schoolrooms, a cosmic riddle embraced by people who never cared for orbital mechanics or spectroscopy. It has crossed the threshold from data to myth. But underneath the noise, the steady hum of scientific work continues. Observatories tuned to the faint glow of reflected sunlight record the coma expanding in irregular bursts, each one a pulse of chemistry speaking across millions of kilometers. The emerald tint reported weeks earlier has grown more pronounced, and some instruments register faint asymmetries in the gas cloud. Jets of material seem to erupt from localized regions of the nucleus, suggesting that beneath the carbon dioxide crust lie volatile pockets waiting for the sun's heat to unlock them. Each burst sends the coma shimmering like a living thing exhaling in the darkness, as though the comet carries memories of another solar system and is determined to release them piece by piece. Scientists argue about what these bursts mean. Some propose that they represent stratified layers of frozen chemistry, stacked like pages in a book written during the comet's formation. Others see evidence of surface cracking, fractures that expose deeper reservoirs of carbon monoxide and cyanide compounds. Still others wonder if cosmic ray bombardment over millions of years has chemically altered the surface into a crust that now controls how the inner layers release their gases. Each model tries to explain the strange dominance of carbon dioxide, but none fully account for its persistence. The comet resists easy categorization, and in that resistance, it forces the scientific community to stretch, to refine, to imagine processes outside the limits of established models. Meanwhile, Mars looms larger in the background. The timing of the flyby cannot be ignored. As the comet approaches, rovers continue to drill, scrape, and analyze the Martian regolith. Samples sealed in titanium tubes await a future mission that may one day return them to Earth. The tantalizing evidence of leopard spot textures, mineral traces suggestive of ancient microbial life, still circulates through conferences and papers, debated but never dismissed. For the public, the combination of these two narratives, Martian biosignatures and a comet exhaling greenhouse gases, blends into a single story, one of resurrection, intention, and destiny. For scientists, the proximity of these developments is maddening. They want to separate coincidence from causation, but the human brain resists. It wants a storyline, not parallel events. The weeks leading up to closest approach become a kind of countdown. Space agencies adjust observation schedules, shifting satellite orbits, reprogramming instruments to maximize coverage during the narrow window when comet and planet align. Amateurs plan viewing parties, even though the comet remains faint to backyard telescopes. Journalists swarm researchers, demanding definitive answers that scientists cannot yet provide. In the vacuum of certainty, speculation thrives. Some commentators speak of terraforming projects initiated by unknown intelligences, others of cosmic seeding, the deliberate transport of chemistry across star systems to awaken dormant worlds. Each theory gains traction not because evidence supports it, but because imagination hungers for meaning. Yet in the laboratories and control rooms, the focus remains sharp. Spectral readings confirm not only carbon dioxide, but now a significant trace of carbonyl sulfide, a molecule sometimes linked with biological processes on Earth. Its presence does not prove life. It can emerge from volcanism and inorganic reactions, but its detection in an interstellar comet raises eyebrows. The idea that a comet could carry a molecule relevant to biology from one star system to another is staggering. Even if entirely abiotic, it suggests a cosmos where chemistry that nurtures life is not rare but scattered widely, waiting for planets to catch it. The comet thus becomes not only a test of imagination but a messenger of possibility, whispering that life's raw ingredients are not confined to one fragile world. As the comet enters the geometry of the flyby, navigators calculate its exact trajectory relative to Mars. Predictions tighten to within thousands of kilometers, an extraordinary precision given the distances involved. The comet will not strike Mars, that much is certain. But it will pass close enough to bathe the Martian atmosphere in its tail, dust grains and volatile molecules drifting across space to mingle with the thin carbon dioxide already there. For planetary scientists, this interaction is a rare natural experiment, a chance to watch two environments collide in subtle ways. Dust storms, ionized trails, chemical reactions in the upper atmosphere, all may unfold in the weeks after the flyby. Instruments aboard orbiters are calibrated to catch even faint changes, while rovers are tasked with scanning the skies for any visible phenomena. The sense of theater is unavoidable. A comet carrying unusual chemistry, brushing past a planet with evidence of ancient life, while humanity watches with its most advanced instruments. It feels scripted, like a drama designed for an audience. Scientists insist that nature has no script, but the public is unconvinced. And in truth, the unease creeps even into professional circles. The timing is uncanny. The chemistry is provocative. The coincidence strains the comfort of randomness. Though no evidence of artificiality has emerged, no radio signals, no engineered structures, the possibility refuses to vanish completely. It lingers like an echo, unprovable yet persistent. As the hours tick down, humanity braces for the spectacle. The comet does not care for human interpretation. It simply continues, obeying physics older than memory. But for us, its passage has become a mirror. It reflects our hopes of discovering life beyond Earth, our fears of cosmic insignificance, and our relentless need to stitch the random into narrative. Whether 3I Atlas is a harbinger, a courier, or merely an indifferent wanderer, its legacy will be the story we tell about it. And that story, already sprawling across cultures and disciplines, has only begun to unfold. The comet drifts onward, a shard of interstellar ice and stone tracing its one-way trajectory through the solar system, and with every kilometer it closes on Mars, the atmosphere of expectation deepens. The world has never been so focused on a single astronomical event, not even during the fleeting passage of Oumuamua or the more conventional Borisov. Those were curiosities, quickly analyzed and filed away in the scientific record. This one has become something else entirely, a cultural event, a philosophical dilemma, a mirror in which humanity glimpses its own fears and desires. Governments track it, children draw it, religious leaders interpret it, skeptics dismiss it, dreamers exalt it. It has escaped the realm of data and entered the bloodstream of civilization. In the weeks surrounding its closest approach, the red planet becomes a stage. Orbiters are reoriented, their instruments pointed outward rather than down. Rovers adjust their schedules to take frequent skyward measurements, pausing geological surveys to capture any atmospheric disturbance the comet might create. The thin Martian air, already rich in carbon dioxide, is about to be brushed by a tail dominated by the same gas, along with dust grains and exotic molecules that may or may not interact with the fragile climate. For planetary scientists, this is a once-in-a-lifetime natural experiment. For the public, it is a drama whose script seems written by forces beyond comprehension. The night of closest approach arrives. Across Earth, telescopes large and small follow the faint smear of light as it drifts past Mars. Live streams broadcast spectral data in real time, graphs dancing across screens while commentators struggle to keep pace with the raw flood of information. Social media becomes a storm of excitement, with images stitched, enhanced, shared, and exaggerated. Some see omens in the shapes of the dust tail. Others declare that the green glow is proof of deliberate design. Amid the frenzy, scientists maintain their composure, though even they cannot disguise the electricity in their voices as preliminary readings confirm that molecules from the comet are indeed mingling with the upper layers of the Martian atmosphere. The first signatures are faint, spikes of carbonyl sulfide, wisps of dicarbon, traces of cyanide compounds. Nothing catastrophic, nothing visible to the naked eye, but enough to shift the composition of the thin sky above Mars by measurable amounts. The rover's sensors detect tiny increases in infrared absorption, the faintest thickening of the already tenuous air. Orbiters report unusual scattering patterns, suggestive of dust grains entering and dissolving. To most observers, these are just numbers, but to those who have spent lifetimes studying the red planet, they represent an extraordinary gift, direct evidence of material from another star system physically mixing with the atmosphere of a planet that once hosted lakes and rivers. The implications reverberate across disciplines. Planetary climatologists imagine how repeated events of this kind, stretched across eons, might alter a planet's fate. Astrobiologists wonder whether interstellar chemistry could seed dormant worlds with the precursors of life. And then comes the human interpretation, layered over the data like myth over fact. Commentators frame the event as a deliberate act, as though some intelligence launched a cosmic courier to deliver carbon dioxide to Mars, just as humanity discovered hints of ancient life there. The statistical unlikelihood of the timing becomes fuel for endless speculation. The scientific community repeats its mantra, coincidence, natural processes, chance, but the words seem powerless against the tide of imagination. People crave meaning, and in the shimmering tail of the comet they find it. In classrooms, teachers struggle to balance excitement with caution, telling their students that science advances slowly, through replication and debate, not sudden revelations. In laboratories, researchers sift through terabytes of data, calibrating, correcting, discarding noise, wary of drawing premature conclusions. Yet even they feel the pull of wonder, the nagging thought that maybe, just maybe, this event means more than numbers can express. In coffee shops and living rooms, ordinary people ask questions once confined to philosophy. Are we alone? Is there intention in the cosmos? Could life on Earth itself have begun with a comet like this, carrying chemistry from another star? Days turn into weeks, and the comet recedes, continuing its escape into the dark. Its influence on Mars diminishes, the dust disperses, the molecules fade into background. The planet returns to its usual silence. Yet the echoes remain. Papers are published, conferences convened, debates sharpened. Some declare that nothing fundamentally new has been learned, that the comet was only another data point, albeit a peculiar one. Others argue that its very strangeness has expanded the boundaries of what is considered possible, forcing us to imagine planetary systems where carbon dioxide, not water, dominates the frozen reservoirs of comets. Still others focus less on the chemistry and more on the cultural aftershocks, noting how swiftly a celestial object can become myth, how easily coincidence can masquerade as design. For the wider public, the comet is already legend. It has been woven into novels, sermons, political speeches, and personal diaries. Some claim it as proof of divine providence, others as evidence of extraterrestrial engineering, still others as a reminder of the fragility and interconnectedness of life. Its legacy is not confined to the pages of scientific journals. It pulses through the cultural imagination, a reminder that the sky above us is not static but alive with wanderers that defy prediction. And beneath all the noise lies a quieter truth. The universe is vast, and coincidences, no matter how uncanny, are inevitable. Objects from other star systems will pass through again, perhaps carrying stranger chemistries, perhaps brushing closer to planets, perhaps striking them outright. This was not the first, and it will not be the last. What matters is how humanity responds, whether with fear, with projection, or with disciplined curiosity. 3i Atlas, indifferent to our interpretations, has nonetheless given us a gift, a chance to see ourselves in the mirror of the cosmos, to measure our hunger for meaning, to confront our limitations, and to stretch toward greater understanding. As the final datasets are archived and the comet dwindles to a faint memory in the outer darkness, one realization lingers. The true impact of the visitor was not on Mars, not in its dust or its carbon dioxide ratios, but on us. It forced humanity to practice patience in the face of mystery, to balance skepticism with wonder, to wrestle with the paradox of coincidence and intention. In doing so, it prepared us for the future, for the next interstellar wanderer, and the next, and perhaps one day for an encounter that truly does reveal life beyond Earth. Until then, the lesson of 3i Atlas is simple yet profound. The cosmos is not silent. It speaks in fragments, and it is up to us to listen without rushing to complete the story before its time.